In the last section, we talked about congruency axioms for triangles. The first, if we're given 3 sides of a triangle, we can use that information to determine the angle measures, because only one triangle exists that would have that information. If we are given 2 sides and the angle that is in between them, we can also determine all the rest of the measures of the triangle. Finally, if we're given 2 angles and the side between them, or really any 2 angles and a side, we can use that information to determine the rest of the triangle, because that third angle is a fixed value. So with that fixed value combined with the side length that we know, again, a single triangle exists and we can determine the missing values. In this lesson, we are going to talk about what's called the ambiguous case. When you are given 2 sides of a triangle and the angle opposite one of those sides, what happens? This information does not translate to a very specific triangle. There are actually multiple options available. The first is simply that one triangle exists. The second is that no triangles exist. And the third is that 2 triangles exist. The hardest part really is being able to distinguish when you have ambiguous case. What you're looking for, your textbook calls it SSA. Something that you may remember from geometry is this, and you were told you are not allowed to use that to prove congruency. So the one that you're not allowed to use is the one that's going to be the ambiguous case. So let's take a look here at some of the cases that tend to show up. The first is that angle A, meaning the angle that you're given is an acute angle. We're going to call the height of the triangle B times the sine of A, because if this had been a right triangle, we would say sine of A is equal to this height over B, and so the height is B sine of A. So if the side length that's opposite the angle you're given, if it's shorter than your height, there are no triangles that will work, because as you can see here, it doesn't connect with the bottom of the triangle. If the height that you're given, meaning the side length opposite your angle, is exactly equal to B sine of A, you'll have one triangle because it connects in one point. I'm going to jump down to this one. If the opposite side that you're given is larger than the height of the triangle, we will have one solution. The place where it gets dicey is here. If the side that you're given is in between the height and the other side, so the side opposite your angle is in between the height of the triangle, which is here, and the second side that you're given, you're going to end up with 2 separate triangles that can exist. So I'll draw them so that you can see them. Here's your first triangle. 1, 2, 3. Here's your second triangle. This is where it gets difficult, and this is what we're going to spend most of our time looking at, because you will always have to check for this. Here, the angle we're given is obtuse. So again, we've got some circumstances. If the side that's opposite the angle we're given, if that is shorter than the other side, we're not going to have any triangles, because as you can see, if I rotate this over here, it'll come out, it won't connect to the bottom of the triangle down here. The second is that the side opposite our angle is longer than that second side we're given. If that's the case, we will only have one solution, because if we swing that around over here, it won't connect. I do not expect you to memorize each and every one of these, but rather to understand that these are the options that you have and that you should always be checking for them. So let's solve some ambiguous case triangles. Here's our first one. Always draw the triangle. It doesn't matter. I draw all of mine to look equilateral. So angle B is 68.7. Side B is 25.4. And side A is 19.6. I know that this is ambiguous case because I've got angle, side, side. That is what tells me it's ambiguous case. So the first thing that I will do is I will solve for angle A. The reason I'll solve for angle A, well, I've got angle B, side A. The only option I have is to solve for angle A. So I will use the law of sines. And from here I will cross multiply, and I find that the sine of A is 0.719, and that angle A is equal to 45.967 degrees. The next thing that you need to understand, and I will explain this by looking back at the coordinate plane. Imagine I have a coordinate plane here, and I've got all students take calculus. And I've got, I'm just going to round this, a 45-degree angle here. The sine of this angle is going to be a positive value. But remember how I made you learn about reference angles? Which would be about here, and this one would be 45. Guess what? The sine of this angle is going to be the same. So how do I know what my true angle measure is? Well, I need to take the supplement. With that being said, when you get an angle, like we have here, you must take the supplement of that angle, because the sine of 45.967 and the sine of its supplement will give you 0.719. So to calculate the supplement, that's simple enough. What this means is that we now have an A sub 1 and an A sub 2. That means angle A can be either one of those two values. Now we need to find angle C. So we can again use the triangle sum to find angle C. So 180 minus my original angle, don't forget to use that one, 68.7 minus 45.967. That will give me angle C sub 1. I'll do the same thing with A sub 2 over here. 180 minus 68.7, so I still am using this angle B because it was given to me, minus my A sub 2, which is here. And that will give me C sub 2. I find that C sub 1 is 65.333, degrees. When I calculate C sub 2, I get negative 22.733 degrees. Here, what I find out, this isn't possible. I can't have a negative angle in a triangle, which means that there's only one triangle that actually meets this criteria. So now that I've discovered that, I can continue where I was and solve for side C. So I will take the sine of B, because that's what I've been given, over B, and that will equal the sine of the angle C that I have over side C. And I learned that side C is equal to 24.775. So this is A sub 1. Actually, it's just A. This is angle C and side C. Since there are not two, I don't need the sub 1 here. I can just leave it as angle A, angle C, and side C. So here's the next triangle. So on this, the first thing that I will need to do is I will need to solve for angle B. So I will take the sine of A over A and set that equal to the sine of B over B. I find that the sine of B is equal to 0.969, and that angle B is equal to 75.811. So for the exact same reasons as before, I need to take the supplement of this angle. And I get that B sub 2 is 104.189. Now I need to calculate angle C sub 1. So I will subtract angle A, the angle that I'm given, and angle B, the one that I've calculated. And I get a value for C sub 1 to be 42.789. Now I calculate C sub 2. And I find that C sub 2 is 14.411 degrees. This is a positive number, which means that two triangles exist with this information. You now have to solve for side C on both triangles. So to solve for lowercase c sub 1, we'll continue to use law of sine, so sine of A over A is equal to the sine of angle C sub 1 over side C sub 1. And for side C sub 1, I get 27.467. Then I calculate side C sub 2 in the exact same way. Sine of A over A is equal to sine of C sub 2 over side C sub 2. And I get that side C sub 2 is 10.063. Continuing on, here's the triangle. Angle C, here they give in degrees and minutes. Again, I see that I have angle, side, side. Not allowed to have that, so I know it's ambiguous case. I have side A, but not angle A, so that will be the first thing I solve for. So I'll take the sine of C over C is equal to the sine of A over A. Remember that you can put this directly into your calculator, even the degrees and minutes, if that's what you choose to do. When I do that, I get that the sine of A is 1.313. This should be a red flag for us because remember we talked about the range on every trig function, and sine can't be bigger than 1 or less than -1. So when I see this, I should think there's a problem here. If you don't automatically recognize that, then go ahead and take the inverse sine and see what happens. Your calculator will say error domain. What that means is that there are no such triangles. And that is the answer. There are no triangles that fit this criteria. This last problem, there really isn't a lot of work that I can show you, but you should understand kind of some of the things that you're looking for. So it says, explain why no triangle exists satisfying this information. Well, the first thing we should pay attention to is the fact that this is an obtuse triangle. Which means that 93 degrees will be the largest side, will be the largest angle. So the side opposite that must be the largest side. Well, taking a look at the values they give us here, what we see is the side opposite angle B is 42. The side opposite angle C is 48. Well, we all know that 48 is larger than 42. You can't have a side larger than the one across from your obtuse angle. So the reason that no triangle exists is because the side opposite the obtuse angle is smaller than one of the other sides given. Is smaller.